Alright, let's look at the homework 16.6, problem number 9. Alright, so let's find the surface area here. Alright, so in order to find the surface area, we need to find the partial derivatives. So we take the partial derivative with respect to u. Alright, so this is going to be with respect to u, so you have a cosine of v and the sine of v, and the partial of v with respect to u is going to be 0. Alright, then partial of r with respect to v would be, alright, so you use it just a constant derivative of cosine is negative, so u cosine of v, and u times derivative, actually, so that would sine, sorry, negative sine of v. And then you have a u cosine of v. And then derivative of v with respect to v would be 1. Right? So let's compute the cross product. Alright, so cross product of partial derivative of r with respect to u and the partial derivative of r with respect to v is going to be, so let's compute that, vector I, vector j, vector k, cosine of v, sine of v, 0, negative u, sine of v, u cosine of v, and 1. Right? So the first component is going to be, alright, so it's going to be sine of v times 1 to minus 0, so it's a sine of v. Alright, then the second component is going to be a 0 minus cosine of v, so it's negative cosine of v. Alright, last component is a u cosine squared minus, so it's plus u sine squared. So u cosine squared and u sine squared is going to add up to be u. Alright, so we have that. Alright. Then if you find the magnitude of that vector, you will get this. It's going to be pretty nice. It's a square root of, alright, sine squared of v plus cosine squared of v and plus u squared. Alright. But sine squared plus cosine squared is going to be just 1. So we have square root of 1 plus u squared. Alright, then all we have to do is we have to integrate. So it's going to be, so area of this surface S, I'm just going to call it S, is going to be double integral, right? Integrand is square root of 1 plus u squared. We can do with respect to u and with respect to v. And u is going from 0 to 1, and v is going from 0 to 6 pi. Right? So this is a separable, so I'm going to just go ahead to do the antiderivative with respect to v. So I'm going to separate that, multiply by integral from 0 to 1, square root of 1 plus u squared du. Right? And the first part is pretty easy. Antiderivative of 1 with respect to v would be v. And you're going from 0 to 6 pi. Right here, I'm going to do it on the side here. So this one that takes a little bit more work. All right, so let's compute the integral from 0 to 1, square root of 1 plus u squared with respect to u. Right? I'm going to use a trig substitution. Let u be, right? I'm going to use tangent. How about that? Tangent of, say, t. Right? So if you take the derivative, du over dt is going to give us secant squared of t. So du is going to be just a secant squared of t dt. All right, then let's see. When you go from 0 to 1, and this is going to translate to t value. Right, so let's say u is 0, tangent is 0 when t is equal to 0. Right, 2. Right, tangent is actually, let's see, tangent is 1 when t is pi over 4. Right, so we got that. Right, so let's rewrite this. So this is going to be an integral, right? Integral from 0 to pi over 4. Then you have a square root of 1 plus tangent squared. So 1 plus tangent squared is secant squared. With the square root, you're just going to get the secant of t, right? But the du is secant squared dt, so it's going to be secant the cube. I'm going to actually write it this way. Secant cubed squared t dt. All right, so let's try to evaluate this guy. So I'm going to try to do, let's try to find the integral of secant cubed of t dt. Let's call this t here, right? So I'm going to split this into integral of secant of t and the secant squared of t. Right, I'm going to use an integration by part. So derivative of secant is tangent, actually secant tangent, right? Antiderivative of secant squared is tangent. Right, so by integration by parts, you have a secant t tangent of t, right, minus integral, right, you have a secant of t times tangent squared of t dt. All right, then we can rewrite, tangent squared as secant squared of t minus 1. So we get this. We're going to get, you have a secant of t tangent of t, right, minus integral of, right, so you have secant cubed, right, minus, so plus integral of secant of t dt. All right, but you know that this is the same thing as the original integral I. So I'm going to say add I to both sides. So we're going to get the 2I is equal to, we have secant of t tangent of t, right? And plus secant of t. Secant of t is natural log of absolute value of secant of t plus tangent of t, right? So since we're looking for I, I'm going to just divide through by 2. You get I is equal to 1/2 secant of t tangent of t plus 1/2 natural log of secant of t plus tangent of t. All right, so we put that back in here. So we're going to have, all right, so we're going to have 1/2 is, I'm going to pull 1/2 out right here. And then we have secant of t times tangent of t plus natural log of absolute value of secant of t plus tangent of t. Right? And then we're going from 0 to pi over 4. Right? So this is going to be, all right, so we're going to have a 1/2. All right, so plug in pi over 4. So the tangent of pi over 4 is 1, and the secant of pi over 4 is square root of 2. So you have a square root of 2 plus, right, you have a natural log of absolute value of, so secant of pi over 2 is pi over 4 is square root of 2 plus tangent of pi over 4 is 1, right? So since this is positive, we don't really need the absolute value there, right? Minus, if you plug in 0, tangent of 0 is 0, and if you plug in 0, secant of 0 is going to be 1, and the tangent of 0 is 0, but the natural log of 1 is 0, so the whole thing is 0, so you just get that. All right, then we just have to put that back in here. So this is going to be 1/2, and you have a square root of 2 plus natural log of square root of 2 plus 1. Right, so this is going to be, this is 6 pi, then with 1/2, so you have a 3 pi times square root of 2 plus natural log of square root of 2 plus 1. All right, so let's type it in. All right, so what we got was, all right, 3 pi times, all right, square root of 2 plus natural log of square root of 2 plus 1. Right, so let's check submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.